Hi everyone. Okay, let's look at something just a little bit less mathy maybe and a little more discrete. The trapezoid rule and actually other rules you could use as well. They actually work beautifully for some really just hands-on real world stuff. So for example, say we want to approximate the area of a lake and we have a lot of shore-to-shore measurements of how far across the lake is. So this one's kind of funny. It's been divided up. It's got like this middle line and then it tells you how far this short is from each side. But we're asked to use the trapezoid rule to estimate the area. So visually, we're just going, well, you have two choices. One, this is funny because usually we just go like if we're visualizing that line across as the x-axis, we just go up or down depending on whether the curve was up or down. So here you could split it into two problems, and in one of them you could go up to the curve and there's your first trapezoid. In this case, since the height is 0, it's actually a triangle, which can happen. And then as a separate problem you could go down. But really, it's also okay for us to just draw the trapezoid connecting and make it go all the way from the top to the bottom. So up to you, whichever one you like, but I would say I'm going to go along and I'm just going to connect the dots and then we'll figure out how tall each of these is. And this is how we're getting our approximation, right? So we can use these for 100% practical everyday stuff. When you've got some sort of curved edge and there's no way you're going to perfectly measure that, but you can do a pretty nice job using these rules. So let's see if I can draw. Whoop, that one was really ugly. And then we'll go ahead and we'll add up the heights so that we get the total. Again, if you prefer, you could absolutely split this into two problems, but we're just going to visualize it this way. Oops, I'm getting a little lazy on them. Okay, so then we're just connecting across all the way. And again, far from perfect here, but this kind of gives you the idea of what we're doing, connecting these points. So we need to figure out how wide each of these sections is. So like what is our delta x? So it's kind of like this is our x-axis sticking out this way. Our delta x, now that I scribbled all over that, what am I seeing? I think I'm seeing the second line is at 40 and the fourth is at 80. So it looks to me like each one of these is 20 meters wide. So when we do our trapezoid rule, we're going to make them 20 wide. And maybe just for good measure, I'm going to count up how many there are in intervals there actually are. It looks like 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14. Yes, which is good because that's how I'd get to 280. So this is really T sub 14 that I'm doing on this irregular shape. And then we're just going to average the two heights, right? So we'll have 0, and then 60 plus 40 is 100. And then we can kind of work our way through. So 70 plus 45 is 115. Oh man, I'm going to have to erase all my drawing that I spent forever on. 86, 136, 140. Okay, I'm going to pause and do some of these, and you can pause too and then check back instead of listening to me do arithmetic because it's very boring. Okay, so I've labeled along all the lines what my arithmetic came up with. I didn't triple check everything, so sorry in advance if there's some bad arithmetic somewhere along the way in there. But that would be the idea, is that you'd find each of the heights and then you'd have to go through and do 0 plus 100 over 2, and then 100 plus 115 over 2, and 115 plus 144 over 2, and then all the way out until we got to 109 plus 0 over 2. Okay, so option number 1, or in the last one I did it that way. Maybe in this one we'll try the left-hand sum and the right-hand sum. You do have to write out 2 things, but sometimes it's just a little cleaner than all those fractions, so this is entirely up to you. We're still going to have widths of 20, so that doesn't change. But now we're just going to list the left-hand side, so we'll go 0, 100, 115, 144. So we're basically just going to make the whole entire list, but we're going to stop at 109. We're not going to go all the way out to that very last endpoint where it's at 0. And then for a right-hand sum, we're going to take 100 plus 115 plus 144. So we're basically just skipping the 0, and we'll keep going. And this time we will hit the 109, but we will also catch the 0 at the end. Notice that the 0 doesn't actually make any difference. So we actually are going to get the same thing from left and right. So hold on, I'm going to go calculate. I'm going to pause. You can crunch it too so you can double check my calculator work. All right, through the magic of technology, you get instant calculation. So I got, oops, except my pen isn't working now. 37,820. And that's actually going to be exactly the same here. So the averaging process is not very exciting, but the idea is to get t sub 14. We would take our L sub 14 and our R sub 14 and average them, but that's still just going to be 37,820. And notice we were units wise taking width in meters and multiplying it by all these heights that were also in meters. So we are getting square meters, and that should give us a really good estimate. So there's a really nice little practical application of a trapezoid rule. Okay, hopefully that'll get you started. Thanks for watching.